In this video, we're going to look at some collisions. Collisions are a really big part of games, and it's all about looking to see whether the player has hit something or something's hit the player. We're already using a collision to see whether the player is hitting the floor or not, allowing it to jump and move around. But we also want to be able to do things like pick up objects, health or collectibles, that sort of thing. We want to be able to detect whether the player has reached the end goal over here. And we also want to detect whether these obstacles and enemies have hit the player. And they're all going to be done in a very similar way. We're also going to look at how some of these objects can be animated using code to give them a bit more of a presence in the game. To begin with, I will start with the most straightforward, which is picking up an object. The pickup mesh that I've got is this cube. Obviously yours might be all sorts of different things, but whatever it is, it must be an area object. If you're not sure, you can find your pickup mesh or your pickup object in your main scene and open it up. Here you can see mine, and it's got that collision shape and it's got an animation attached to it that makes it spin around. If you're not sure what's going on there, check out the previous videos to catch up. The type is an area. If it's not, you can right click, choose change type and choose area from the list. Back in the main scene, we're now going to add a script to our pickup which finds out whether the player has hit it, and there's a few things that Godot can do that will help us along the way. First step is to create the script. So with the pickup selected, we'll press the new script button. Keeping these default settings, and here we can see the script template. Once we've got our script, we could of course start writing things in here, and we will come back and write some more things in here later on. But for now, we can use one of the sort of built-in features of Godot, which is this idea of nodes and linking things together visually. And to do that in Godot, it's called using signals. To access the signals of any object, we have to have the object selected here in the scene panel. Over here in the node panel, we can see all the different signals for this particular node. And if I just change the type of node, so I'll change it to a kinetic one, you can see the types of signals change. That's why it's really important to have these sorts of nodes for the different objects so that we can use appropriate signals to help us make the game. Back to the pickup mesh, we are going to look for when something enters this object, when another mesh is within its mesh or its collision boundary. And so if we look at the signals here, we can find one that says body entered. And if we double click that, it brings up a dialog box. It says, what are we connecting from and what are we connecting to? You can only connect to objects that have a script. If an object is grayed out here, it's because it doesn't have a script, so you won't be able to connect to it. So if you need to, cancel that, go to the particular object and add a script. You don't need to write anything in it, but it needs to have a script attached for this to work. We're actually going to connect this signal to the pickup mesh, so it's connecting from and to this particular object. Having selected that in the list, I'm going to click connect, and you can see now that to our pickup script, it's added this little function, and handily it's got this little signal identifier here, so we can kind of track back and see where that's coming from. Nevertheless, it's given us this new function on pickup mesh body entered. So you see it's got the name of the object and then this body entered thing and then body. The reason body is in brackets here is this function needs a bit of information called body to actually work. It will actually react to any of the other meshes using this particular method. So we need to kind of narrow it down a little bit because we don't want this happening if, say, an enemy passes through it. So first we need to check that it is actually the player. So we're going to write if body is kinematic body, like that, colon. So we're saying when our pickup is entered by another mesh, another body, and if that body is the player, is a kinematic body, and our player is the only kinematic body we've got in this game, we're going to remove the pickup. To write this, we use the term q underscore free, and then parentheses. If this hasn't gone blue, and your colours are looking different to mine, then just double check that everything is spelt correctly. What this should do is when the player hits the pickup, it disappears. I'm not going to do much more to it than this, but you could of course start to play with this in terms of other variables. You could make a variable called health, for example, and have this add 1 to that value and things like that. So hopefully this gives you a starting point for things that happen on the mesh, and I'm sure there's lots of information out there on what other people have done. But for now, we're just going to have this remove it. Another useful thing to do is when debugging, we can look at whether our scripts are working by using a function called print. And we write that like this, print, and then in brackets, we say what we want it to print. And I want it to print picked up. I've written this in quotation marks, and it will appear in our output here as we play the game. And it's a really useful way of getting some instant feedback from our game while we're testing it. Rather than making particular things happen, we can really just double check that code is working as we hoped, with little notes to ourselves that appear as things happen. To demonstrate, I'll save this and we'll press play. And I'll get the character to walk along until they hit that pickup. We can see that the pickup has disappeared. The player's sliding down the hill. We can also see that in this output window we've got the words picked up, which shows us that that is working as expected. And as I say, using the print command is a really useful thing to do during your coding, just to make sure things are working without having to have so much going on. You know, if we wanted sounds playing and things like that in the end, that takes a lot longer than just writing print this sound is playing while we are working out our code. So it's just a quick method of making sure everything's working. For the time being, that's all there is to the pickup, and we're going to use a very similar technique for every other object that we collide with. The next is going to be a kind of anti-pickup, a trap, something that we can collide with that is going to hurt us. And for that, I've got this one called trap. If we take a little look at that, you can see that it's a simple mesh of triangles and this convex collision shape to check when the player has hit it. I'll go back to my main scene, and again I need to add a script to this trap. Keep the default settings and press create. And now I've created that, once again I'm going to go back over here to the trap mesh. Over in the node panel under signals, I'm going to choose this body entered option. Again, connect it to itself. And we're going to write the same thing, so we may as well pop back to the pickup script. I'm just going to grab this line here and copy that back to my trap, and here just replace pass with that. And we're going to decide what happens when the player hits it. And for the time being, I'm going to write print die. Because there are going to be multiple ways to die in this game, I'm going to put the word trap afterwards so I know exactly what's killed the player. And I can test that in the same way. Die trap. There we go. And of course the pickup still works as well. The next object I'm going to work on is the goal. So what happens as a result of the player getting to the end of the level. Using the same process as before, I will add a script to my goal, keep these settings, click on this mesh again, and then in the signals choose body entered, connect it to itself, and code again. I should have probably pasted the print bit as well. But here I'm going to write you win. It's a good idea to test it each time, and of course I could have moved my player close to the goal. There we go, so I've got all three of my prints happening as I move through this level. To make the level a bit more interesting, I'm going to add animation to some of the other objects that I'm going to collide with. I'm going to start with these spikes. These spikes are going to move up and down, and when they're up they can hurt the player, and when they're down they cannot, and the player can walk safely over it. I need to set up that animation, and I need to do it in Godot. If I'd have set up the animation in Blender, as I had done, I found that the collision mesh wouldn't stick to this object as it animated, it would just do the whole thing. And so actually it didn't work as I wanted it to. Either the player would collide with the whole thing, or not at all, regardless of whether it was hidden. So before I add the signals to make the collision work, I'm going to do some animation. To do this, I've got the spikes selected. I'll just make sure that I've got them reasonably in view here so I can see what I'm doing. And I'm going to go to the animation window here. When you open the animation window, it may ask you to select an animation player. In this case we don't have one, so we need to add one. Making sure I've got the spike selected, I'll press the plus button and choose animation player. With that selected, you can see that this is a child now of the spikes and attached only to it. I can choose Animation, New, and I'll call this Spikes Action to match the way that some of my other animations in this game are written. Obviously, you can use a name that is useful to you. This opens up our animation track and it gives us this Spikes Action name here. Now we can add tracks here, but a simpler method is to simply click on the spikes here and go back to the Inspector panel. Coming down the panel we find Transform, and this is where we can control some of the movement of the spikes. First I'm going to put them in their correct starting location by just scrolling this number in the y-axis. Having got it in the right place, I can click this little key here and it asks me to create a new track for the property translation and insert a key. So I'll press create, and what we can see is that it's added this bit of information to the timeline. So we've got a track for translation, and we've also got our first keyframe. The animation is currently set to last just 1 second, so I think I will change that to 3. And what I'll do is I'm now going to move this timeline indicator on to the number 1, and I'm going to change the translation here. I'm going to set it so that it comes down just below the ground like that, and I'm going to press this key. So now we've created a small bit of animation that lowers the spikes. Then I'm going to move on to the number 2, so the second, and I'm just going to put them back into their original position by clicking the first keyframe here, right click and duplicate key, and that will put a new key, identical key, at this time here. And we can see that we can go up and down. We can get a sense of how long that takes by pressing the play button. And I'm just going to knock it down by 1 second, so it only needs to be 2 seconds long. I'm also going to set it to loop, and we can see that happening like that. And I'm also going to press this button that makes it start playing the animation as soon as the game loads. To see that in action, we can test it. And you can see them here going up and down. Probably a good idea to stop animations if you're not looking at them for some reason. And now we continue to make the collisions with the same method as before. With the spikes, we choose add a script and create that. Then clicking on the mesh here and choosing the nodes, we can choose body entered, choose the spikes mesh or whatever your obstacle is. And again here, I'm just going to paste that line, and this time I'm going to print die spikes and save that. We can check that. It's always a good idea to really check as you go along, rather than trying to unravel loads of code that does different things. And you can see here it's happening each time those spikes come up, just as I intended, so that's great. We can also animate objects with code, and for this thing that's chasing the player, this big triangle here, that's what I'm going to do. I'm going to do a combination of timeline animation and scripted animation. So that we can see the results of our scripting, I'm going to move this triangle a bit more into the camera's view. And I'll just check that I can see it. Good. So this is just a straightforward triangular mesh with a triangular collision shape attached to it. I'm going to add a new script and press create. And what I'd like this triangle to do is move from the left to the right, chasing the player, but I also want it to spin round. I want it to spin round on its Z axis, which in this is sort of front to back, if you like, from the front to back. So it will appear to rotate clockwise. And so what we're going to do is we're going to add a little bit of rotation every frame. We're going to need to uncomment this func process delta and delete the pass line. To make this spin is pretty straightforward. It takes one line of code, and so I will indent so that this takes place in this func process delta. So every frame we are going to rotate on the Z axis, rotate underscore Z, and degrees to radians, so transforming the amount of degrees that we put into radians that Godot understands. and then in brackets I'll put minus 90 multiplied by delta. And you can change this value here, the minus 90, to whatever suits you. I've put minus so that it rotates clockwise. If I didn't include the minus, it would rotate the other direction, and it's rotating this amount of degrees each time. To have a look how this looks, I can press play, and there I can see it spinning away quite nicely. To explain why I've scripted this rather than animating it in the timeline, I'm going to click on the chaser mesh here, add an animation player, and now I'm going to add some other animation to this triangle, this chaser. So I'll select its mesh and move it into its starting position. So it's going to start here just before the start of the level, and I'll put it up here a little bit so it looks good while it's spinning round. If you have an enemy like this, obviously you can position it where necessary, and then as before I'm going to come over here to the inspector, twirl open the transform section, and of course we have to make a new animation here. I'm going to call this chaser action and press OK. In the same way that we did with the spikes, I'm going to record its translation using keyframes. So its starting position, I'm going to keyframe there, and it asks me again to create that new track, and then I'm going to decide how long it's going to take the player to complete the level. And don't forget, you can always come back and edit this. I'm going to make this 15 seconds, and there you can see this grey part of the timeline, the active part of the timeline, is now available to me. I can go all the way up to 15, and I'm going to just position this enemy on the other side of the level like that. So during the course of those 15 seconds, this triangle will move from here over here. I need to set a keyframe for that new position. You can see I've got one at the start and one at the end. We don't need to loop this, but we do want it to start automatically. If you'd like to pause it for a moment to allow the player a little bit of a head start, I'll perhaps move mine to 2, and all I'm going to do is click that first keyframe, right click and choose duplicate keys, and that will hold it there in that position for a couple of seconds, and then it will start to chase the player. You can see that it's not rotating in this view, it's only doing the left to right transform. However, of course, our script, when it's running, will start to rotate it. Now the advantage of doing it like this is that we've got a separate rotation to the track here. If we were to rotate it in this timeline, we would be having to change the amount of rotation as we change these frames. You can't have a shorter animation loop. If we were to add a short rotation, so let's say it rotated 4 times over the course of its transition from one side to the other, we couldn't loop that separately. We'd have to keyframe all of those loops, and to be honest, it's a bit of a pain. Also, if we were to develop this game and make more levels, I could simply change this animation for each of the chasers on each level. So I could have it, you know, move up here or whatever on some levels, or have it go diagonally. And the rotation is kind of kept separate. It's always going to rotate. We can then just change and animate its path, and we would add those extra keyframes in just the same way. Move the timeline indicator and press the little key button. So now you can see that the triangle does this kind of thing, which I don't want it to do. So I'll just undo that. Obviously, you can animate yours however you see fit. If you were making a character that chased the enemy and you saw it running, you might like to do the run animation in here and then script the movement across the screen. So you're adding a certain amount to its position each time. So there's lots of ways you can combine these two methods to get the results that you want. I'm going to test this now and just check that it's all working. So we should see after a couple of seconds the triangle starts to move across and it's rotating as it does it. Great. And now of course we need to add the collision to it. So we've already got a script. All we need to do now is choose our node, and we want body entered again. Connect it to itself, and we can paste that line of code, and this time I will print die chaser. We can make sure that's working. There we go, and that's appeared there. So that's working as it should. The next object that is going to hurt our player is going to be a falling object. And here's the falling object. It's this little triangle here. And this is going to fall as the player is walking along. So at some point here we'll need to trigger it off, and once that trigger is set off, this will fall. We need to think about where we need to place the trigger. We can't place it on the object itself, it's too high, the player won't reach it. If we place a trigger directly underneath, the player will be gone before it has a chance to hit him, and so won't be a threat at all. So we're going to need to make a trigger that is sort of offset from our actual mesh. I'm going to begin this one in the same way that I did the chaser. I'd like it to rotate as it falls. I'm actually going to make all of the movement for this object using script. So the first thing to do, having selected the falling mesh, I'll choose attach a new script and press create. To begin with, I need to make the object fall. So I'm going to give it a speed. Var speed equals 40. You can change the speed to whatever suits your needs. Then just uncommenting the process function here and removing that pass line, I'll make my first indent and we'll say rotate Z, just in the same way we did before, and I'll do it about the same speed, minus 90 multiplied by delta. And we could check this at each stage to make sure it is actually working as we think, but I'm going to go ahead and do the next one here, and this is going to allow it to fall down. Now this object doesn't have gravity attached to it. Instead I'm just going to write a bit of script that moves it by the amount of speed each frame downwards. So I'm going to write this, transform dot origin. So what we're saying is move the origin in the y-axis. So we're going to put minus equals because you want it to go downwards, not upwards, not float off into the air. So minus equals speed, so this speed up here, multiplied by delta. So with these two instructions, it should rotate and drop downwards, and we can check that now. And there we go, it vanished before we even really could see it. The problem is now that it's falling when we don't want it to fall. But fortunately, we can create a variable that is either true or false, and we can check to see whether it should fall or not using that variable. So the variable I'm going to create is called fall. I've just named that myself, something useful that makes sense within the context of the script. And I'm going to make it equal false. So we're creating this variable fall and we're setting it to false. So we're starting this game by saying don't fall. On its own, this variable doesn't really do anything because we haven't linked it in any way to this. We need to stop this from happening unless fall is true. So the point at which the fall has been triggered. So we're going to write an if statement around these bits here. So just underneath func process delta, we're going to write if fall is set to true, colon, do these things. Because these are supposed to be in the if statement, you can see here we've got an expected and indented block after if, which is telling me to just nudge these in a little. So now fall is false, and these are going to wait until fall is true to actually fall. The problem is we haven't got anything that switches fall from false to true, and that's where our collision comes in. If I show you what happens at the moment, it's just going to hang there in the air as though we've done nothing to it, which is no good. We want fall to set to true when the player hits the trigger, and so we come back to our mesh and we're going to add an area node to it, and I'm going to call this trigger. We have a warning because this area has no collision shape, so we need to add that, and the collision shape needs a shape. I'm going to make it a box, and there it is. Clicking on this trigger here, I can now move this down. If you need these arrows, you can press W. And so I've got this box here that I can place, and I'm going to make it a bit bigger, so I'll press R and make it a nice size so the player can't fail to hit it. And I'm also going to move it back a little from where the actual object is. So when the player gets to this point here, this will start to fall and hopefully give the player something to contend with. In this instance, our mesh is not the trigger, it's this, and so we need to use the node attached to this area. So having selected the trigger, I come over to node, and this is where I'm going to use my body entered. However, I'm going to attach it to the falling mesh here and click connect. This just helps keep the code nice and tidy. And as before, I'm going to paste in my kinematic body thing, but here I will write something other than print. I'm going to write fall equals true. If I want to add a print command just to make sure things are working, because it may be that some of the animation is messing it up or something like that. So we might want to check that we have actually triggered this off with a print command. I'm just going to write falling, and then we can test that. So you can see that if I just let that pass, I should hopefully get to a certain point, and there we go. So that it printed it as well, and we saw it visually, so that's great. It seemed to go quite fast, so it may be that I need to move the trigger, or just perhaps test it again and not stand still quite so long. Yeah, that's going much too quickly, so I think I will reduce the speed, maybe halve it, see how that affects it. Oh, that falls nicely on the player there. So they would definitely have to stop and wait for it to fall or risk dashing through. Alternatively, of course, I can go back to my main scene. I can grab that trigger and perhaps move it a touch closer to the falling thing. So adjust these as you need to and give it a test to make sure that it works. Do make sure that your objects are in line with the player so that the player does actually connect with them rather than just walking past them. And so now we've created a variety of things that can hurt our player, as well as things that the player can pick up or collide with to say that they've won the game. However, at this stage, it's all text-based. We're not getting those visual responses like we would expect in a game. So let's make the reactions to these different obstacles and pickups a bit more visual. So let's make the results of these collisions a bit more visual. And obviously you can do this in whichever way you see fit. But what I'm going to have happen is for the player to be essentially knocked off the level and killed and then have to restart. Or alternatively, a little screen comes up saying, you've won. I'd also like to make it so that if the player falls off the platform at either end or in this gap, that is also a cause of death. To begin with, I'm going to make an empty area that surrounds the level. So with my main object selected, I'm going to press the plus button and I'm going to make an area. This area needs a collision shape. And I'm going to make that shape a box. You can see it right here in the center. And what I'm going to do is just stretch that out by pressing R and scaling it right up in the X-axis and the Z-axis so that it's much wider than my level. Then I'm going to move it downwards a suitable amount, something like that. This is going to be something that checks to see whether the player has hit it, and if it has, then something's clearly gone wrong somewhere and the player has fallen off that ledge and not made it to the end. And for that reason, I'm just going to rename this Abyss. You can rename it whatever you like, but as long as you know what it is, that's the main thing. And with the Abyss selected here, I'm going to add a script, create it, back to the Abyss, body entered, and choose it, wherever it is, there it is. When the player's gone into this is where it's really going to end the game or restart the game. And so the code I'm going to use here is if body is kinematic body, if it's the player, get tree, brackets or parentheses, reload current, and you can see it's appeared in the list there, reload current scene. So as soon as the player goes into this area, it's just going to reload the scene and reset everything as it was when we started. So I'll press play, and you can see if I just drop off the edge there, there we go. And there we go. That's nice. So that's a way of us losing the game and resetting it. Now I could use this for each of the collisions if I just wanted to reset the game, but I've actually got on my player this death animation. If I open the player up, we can see it in the animation player where it goes, oh no, like that. And I want that to play when the player knows that doom is inevitable. So for this I need to add something to the code for each of the different ways to die that is going to allow that death animation to play. So let's begin with this trap here. So I'll find it in my list here. And if you've still got lots of things like I have starting to twirl open there, just you can tuck them all back up like that to keep it a little bit neater. With this trap mesh selected, I'll go to the script. The first thing we need to do is tell it which animation player we're going to use. So we're going to use an onReady variable again. So it needs to load this before anything else happens. OnReady var, I'm just going to call it a player, animation player, and it's going to equal, we need to tell it which animation player it is. So we're going to make this variable the animation player node of the player node. So to do that, we write get underscore node, and then in the brackets, in quotation marks, we're going to write ... This indicates that we're looking for nodes in our parent node. So in our main scene, it looks at all of these. If we don't add these two little dots and a /, it'll think that we want to look within this object itself. The next thing is to write player mesh. Notice that I have to spell it in exactly the same way that the object is named here. So what we're looking at is this player object here. We're getting this node so far, but actually we want to do another / and type in animation player. So this is the path to the animation player node here on the player mesh. We can use this variable later on down here then, and I won't delete that. I will add a new line. So as well as printing die trap, we're going to write a player play play, and then we can tell it which animation we want to play, and in this case it is the death animation, and we can test that by pressing the play button. There we go. So several things happening at once there, but you can see that it plays that animation when death occurs. If it's not working for you, or you get an error of some sort, do double check that the path is correct and spelt correctly here. So to check it, you should be looking at these objects over here and delving into them a little bit just to make sure that things are spelt correctly. As well as playing the animation, I want to chuck the player off the edge so it falls into the abyss and ends the game or restarts the game. So to do that, I'm going to add some more code here that moves the player into the right sort of position. I'm going to use a similar method. To recognize the player and move the player. So I'm going to write onReady var, and here I'm just going to call it player because I haven't used that one already for anything and it seems useful. And just as below, we're going to do get node, and then in brackets, in quotation marks, and this time we'll stop at player because that's what we want, a player mesh. So here we will write player transform origin Z, and I'm going to make it +=10 for the time being. I might change that. You can obviously change yours to whatever you think it should be. Okay, and then I'll test that. And it's clearly moved it. You can't tell here, but it's no longer colliding with that object. So I might make this a bit more extreme. There we go. And it appears a little bit strange because it's got closer to us as well as falling off the edge. So that's obviously a bit too far. So perhaps if I go somewhere in between. I'd also like to move it up. Player transform origin Y += I don't know, 5 maybe, and I'll test that. You can obviously have whatever you like happening. So it's definitely pushing it off the edge, but it's doing it a little bit strangely. So I think I will make that a little larger again. So these will probably take a little bit of trial and error if you're doing it using this method. I'm also going to move this down so there's a bit more space to fall. So here where we've got the abyss, I'm just going to move that down like that. So having a look at the script for the trap then, I'm actually going to copy this bit. I'm going to copy that to each of the other things that are going to hurt me. So working my way from the top, we've got the chaser here. So I'll click on the script and add that in there. I could of course type the other stuff, but I'm actually just going to copy and paste it. Falling, I'll change the script there. I'll just add it in at the top. The trap I've already done, and the spikes are the final ones. Then back to the trap here. I'll just refine these before I copy them. I also want to add another bit of code, because if we just take another look at the game being played, you can see that whilst it might do some of the things, it doesn't quite play the death action and fall and things like that. And that's because naturally I've still got my hand on the keys and I'm still pressing right, and that's overriding the death action. So we need to tell the game whether this player is alive or dead. And so anything that kills the player or restarts the game, I'm going to put in here player dead equals true. At the moment, there is no such thing as dead to be true or false. We haven't set it up. I'm going to go over to the player script here, and at the very top, I'm going to create that variable var dead equals false. So at the start of the game, dead equals false, otherwise known as alive. Now, having created this variable, we can work with it in our code. Here in the physics process section, I'm going to make sure that all of this code doesn't take place if the player is dead. So we don't want anything else to override it. The only thing I don't want to be included in it is this bottom bit here. So at the top here, just directly under physics process, I'm going to write if exclamation mark dead. So if not dead, and then just select everything like this apart from that bottom section, and I want to make it indent once so it sits within that if statement. So if it's not dead, then do all of this. If it is, and I can add this here and remove it actually from some of the other scripts that I've written, we can say if dead new animation equals death action, and hopefully when we play that, it plays the action, but of course we've lost gravity, so we might need to just put that back. And so we can bring back some of our physics when the player dies by adding it in again here. We can actually just grab bits from our code, so I'll use this velocity y, and I'll paste that in here to set a velocity for the y-axis, and then we'll make that actually do something with the move and slide. And I also need to just give gravity a value here, so I might make it minus 50, something like that. And what's good about this is that for any other script, all we need to do is set dead to true, and it will perform these actions. We don't need to keep rewriting it every time. So we'll give that a quick test. There we go, and you see it hits that area and it brings it back there and works as we want. Obviously you can make adjustments, but you'll want to do that individually, so I'm not going to be too nitpicky with this. So bearing in mind we can just set dead to true to set off these actions here and stop these actions here, we can go back to our main scene and have a look at those scripts. So here in that original one, the trap mesh, I can actually just remove those things and use player dead equals true, not forgetting that we've got that player mesh path up there to refer to it. So I'll copy that line and we will go through, and I'll choose this chaser first and paste it in there, and I will just remove that animation player, we don't need that anymore. The falling mesh script, remove that one. We need to keep that, but then we can just add in the player dead at the end. We need to keep that fall thing, so don't replace everything, just add that to the bottom. The traps we've done, and finally the spikes. like that. So now we've made each of the scripts send back the information to the player script that the player is dead. In the player death code, we can also make a velocity for the z-axis. So velocity.z plus equals 10. And again, this might take a little bit of trial and error. I want it to push off the edge so it falls off a bit fast. I think I'll put that down. So actually what I've done there is make it increase by 10 each frame. I only want to push it a little way, so I'm actually just going to make it equal 10, see how that works. Oh, eventually falls off, so I think I'll just notch that up a bit. Again, you can try yours, see what works for you. Great, that throws me nicely off the edge into the abyss and restarts the game. With any luck, if I can actually navigate the game. Oh, so we can give ourselves a bit of a chance to complete the game by rearranging a few things perhaps. So this, I think the trap can probably come forward a little. Perhaps these spikes could move over a little. And it may be that we have to adjust the speed of the triangle. And I think this might be an opportune time to just have a look at the player mesh and try and sort out its collision shape so that it's not quite so floaty. Something like that. I'll save that and we'll test that. And I see what I've done wrong is I've actually added death to this trigger here. So the falling mesh script, I need to take that off there, and we're going to need to add some script to the actual falling mesh here. So choosing it from the thing, what we did is forgot to use our body entered on that mesh as opposed to the trigger. You can see the difference between the two. One is the on falling mesh body and the other is the on trigger body. We'll remove this pass line and put in our if body is kinematic body, then we can die. And hopefully we won't hit that invisible wall of death this time. Instead, our object falls. We can see that the chaser is going quite fast, and it may not be possible for us to complete the level before it catches us. If you're really having trouble, then obviously you have control over how the game works, and so we could, for example, go to the chaser thing here and we can actually just comment out the player dead bit, Alt and 3, or whatever key combination allows you to put a hash on the screen. And this time the chaser isn't going to hurt us, so I can stand there while it just passes through, and I can just check that some of these other things are working. You win. Now the chaser is going too fast, so I'm going to make it last a bit longer, and for that I need to twirl it open, choose the animation player, and all I'm going to do is change this to 20. I can zoom out a little bit. I'm going to grab this keyframe here and drag it up to 20, making sure I've uncommented the death there. So hopefully now that will take a little bit more time and I'll actually be able to stand the chance of succeeding at the game. Okay, so I win. Oh, I've fallen off the edge anyway. I walked off the edge. So there we go. So that's most of our interaction set up there. One thing that is missing is some sort of screen to tell you that you've won. And so we're going to set that up now using a very, very simple method. But again, you can adapt it to your own needs. In the main scene, I'm going to add a panel. I'm just going to make it a bit larger so it fills this screen here. I'm not going to do anything fancy with it, but if you do want to change any of the settings to this panel, there are a few things you can alter here. With the panel selected, I'm going to add a label. This could quite easily be an image or something like that. I'm just going to zoom in and I can make this label a bit more central. And over here on the right, I can type in "you win" or some sort of celebratory message. Shrink that around a bit. I'm just going to align it centrally and put it somewhere in the middle, something like that. I'm going to rename this "win panel." Because we want this to be associated with winning the game, and we win by arriving at the goal, I'm going to click on the script for the goal. And in the same way that we communicated with other objects before, I'm going to create an onReady variable called win, and that is going to equal get_node, and then the /win panel. And at the start of the game, I want to hide this panel. So I'm going to choose win, hide, like that. And when we want to show that we've won, we're going to write win, show, like that. Give that a little test. Hopefully we'll make it to the end of the game. Hurrah. Now what's happened is that once I've reached the goal, the win panel's shown up and this chaser has still come in and hit me and it's reset the game anyway. That could be something that you want to happen. However, you may also want to stop it and just have the game end there. So at the same time, we can actually communicate with the chaser to tell it to stop or not hurt us. So we can write onReady var. Again, I'm just making up the variable names that suit my needs and making sure they're not reserved words. And I need to put that in quotation marks. And this is called chaser mesh. And down here I can type in chaser Q-U-E-U-E free. And then some brackets or parentheses. That will remove the chaser from the scene once we reach the end and prevent the enemy from ultimately winning. So this time round, we shouldn't see our player fall off the edge and restart the game, which is what we want. So at this stage, we've got a functional game, and hopefully there's enough information there for you to start experimenting with your own scripts and the way objects interact with each other. But there's one big element that's missing, and that is audio. And so the next video in this series will be how to add audio to your game.